So the answers to the questions on page 9. Number 1, we need 2 columns for heat and temperature. I take statements and fill them in. Is measured in degrees Celsius, is under temperature. Is a type of energy, is heat. Is a measure of the average kinetic energy. Look carefully at these words. That's temperature. That's kind of bold or underlined. Measure of the average kinetic energy. Or in everyday words, how fast they're moving, but for all the particles in a sample, in a material. And also can be measured with a thermometer. Heat is measured in joules. That's the unit, usually abbreviated as capital J. And what it means then is a measure of the total. So that's a slight difference between these two. And just one word's difference, but makes a huge difference in terms of what it means. And hopefully that will come clear as we go through these questions as well. That was question 1. And so number 2, we have 0.2 kilograms of water and 0.8 kilograms of water in 2 beakers, and they're both supplied with the same amount of heat. And the 0.2 kilograms of water would be hotter. So they've both had the same total energy supplied, so the same heat supplied, but in B you could answer quite simply and just say there's less mass in this beaker. And then you could go on a wee bit and just think about that idea. What that means then is that heat energy, it's the same total heat energy that was supplied to both beakers, but it gets spread across less atoms, less particles in the 0.2. So on average, each of them will get more of that. Okay? It's like the same size cake. In one case it's getting split between 2 people, and in another case it's getting split between 8 people. The 2 will get a bigger share, bigger slices of the cake. There's less mass in the beaker, meaning each so that hopefully helps demonstrate the difference between the heat and the temperature idea. In question 3, let's say the water, and remember there were some typos in this one, so it should say in the second sentence, in 2 hours the water has reached room temperature of 20 degrees Celsius. So the water has absorbed heat energy from the room. Causing it to rise in temperature. And if it's rising in temperature, the kinetic energy of the particles of water is increasing. So the heat coming from the room is basically getting spread between those particles of water. And a new page, this last one, number 4. So we've got a kettle of water and the same amount going to a swimming pool. So it's very similar to question 2. So for the swimming pool, there's much more mass in the swimming pool. So the energy is spread between a larger number of particles. Meaning each gets less energy. On average, you're not going to get them going much faster. So we're talking about small increase in temperature. Now you could have answered that the other way around and said the energy for the kettle is spread between a smaller number of particles, meaning each gets more energy on average and the temperature increases by a larger amount. Quite often you can answer questions in alternative ways like that. So check your answers and make a note of any corrections that you need to for those.